plants? I am Toni Maristela Cunanan from Grade 12 Archimedes. Look at the things around you. Today, we are going to tackle what they are made up of. Our first topic: the molecular perspective of chemistry. Matter. The phone or any gadget that you are using right now is a matter. The plants that provide oxygen for us is also a matter. The foods that we eat are considered matter. The chair that you're sitting in right now, bags, and even clothes are matter. In short, matter is anything that has mass and volume. Next to matter is molecule. A molecule is a group of atoms that are bonded together. Let us take water as an example. These are the molecules of water. A water molecule has one oxygen and two hydrogen. That's why it's called H2O. Lastly, atom. Atoms are the basic units of matter and the defining structure of elements. It is the smallest unit of matter. Our second topic: the classification of matter. Matter can be classified according to their physical and chemical properties. Color, melting, and boiling points are the physical properties, while flammability and reactivity are the chemical. What are the states of matter? We have the solid, liquid, and gas. First is the solid. The particles of solid are tightly packed and usually in a regular pattern. Liquid particles are close together but with no regular arrangement. The particles of gas are well separated, also with no arrangement. Next, pure substances and mixtures. Pure substance is a matter that has a fixed position and distinct properties. Under this are the elements and compounds. Elements are composed of only one atom, while compounds are composed of two or more elements. Mixtures are a combination of two or more substances. Homogeneous are the mixtures that are uniform and also called solutions, while heterogeneous are the mixtures that are not uniform. Third is the separation of mixtures. Components in a mixture retain their own properties. They can be separated by the different properties of each substances. Methods of separation include magnetism, filtration, evaporation, distillation, chromatography, crystallization, and manual separation. Let us now move on to elements. Over 90% of the Earth's crust consists of oxygen, silicon, aluminum, iron, and calcium. The human body also consists of 90% of oxygen, carbon, and hydrogen. Finally, compounds. Law of constant composition or law of definite proportion states that the elemental composition of a pure compound is always the same. Our third topic: properties of matter. Physical properties are the properties measured without changing the identity and the composition of the substance. Chemical properties are the properties in a way a substance may change or react to form other substances. Intensive properties are the properties that do not depend on the amount of matter in a sample. These include temperature, boiling point, concentration, and luster. Extensive properties are the properties that depend on how much a matter a sample contains. These include weight, length, volume, and entropy. Let us now move on to changes. These are the physical and chemical changes. Physical change results in a change in appearance but not the composition. Examples are melting, shredding, and chopping. Chemical change results in a chemically different substance. Examples are combustion, rusting, and rotting. Our fourth topic: units of measurements. The natural sciences begin with observation, and this usually involves numerical measurements of quantities such as length, volume, density, and temperature. Most of these quantities have units of some kind associated with them, and these units must be retained when you use them in calculations. Measuring units can be defined in terms of a very small number of fundamental ones that, through dimensional analysis, provide insight to their derivation and meaning. International System of Units. There are 7 base units. Prefixes. 10 raised to 6 is mega. Cube is kilo. 10 raised to negative 1 is deci. 10 raised to negative 2 is centi. 10 raised to negative 3 is milli. 10 raised to negative 6 is micro. 10 raised to negative 9 is nano. 10 raised to negative 12 is pico. Lastly, 10 raised to negative 15 is femto. Next is length and mass. Meter is the SI base unit for length. For the mass, it is the measure of the amount of material in an object. Temperature. Celsius and Kelvin scales are commonly used in science. They have both equal-sized units. First is Kelvin. The formula for Kelvin is degrees Celsius plus 273. Second is Celsius. The formula is 5 divided by 9 times degree Fahrenheit minus 32. Last is Fahrenheit. The formula for Fahrenheit is 9 over 5 times degree Celsius plus 32. Next to temperature is volume. The SI unit for volume is cubic meter. Equipments used to measure volume accurately are the syringe, burette, and pipette. Finally, density. To get an object's density, we have to divide the mass by its volume. That's it, new normal students. I hope you enjoyed our discussion and have a great day.